Welcome to qnawire.
Hi, so over here we want to match the following solutions, which are going to be given the concentrations in molality with the highest, second highest, third highest, and the lowest boiling point respectively. So in order to do so, remember that the change of the boiling point is going to be equal to band gap factor times the molality times the boiling point increasing constant Kb. Thus, we know that delta Tb is going to be proportional to I times m. Thus, we want to calculate this value for all of the substances. In this case, we want to calculate first of all what is going to be the value for I, the Van Hoff constant, which is related to the number of ions that are going to be produced in solution. For sodium hydroxide, the value for I is going to be equal to 2. For sodium phosphate, I is going to be equal to 4. For potassium iodide, I is going to be equal to 2. And for a non-electrolyte, the value for I is going to be equal to 1. Thus, we can calculate directly I times m. So for the first one, it would be 1.155 times 2, which is 0.31. For sodium phosphate, it is going to be equal to 0.40. For potassium iodide, it's going to be 0.185 times 2, so 0.37. And finally, for glucose, it's going to be directly 0.34. So with this, we can order the highest boiling point with IM. So the higher the value of IM, the highest the boiling point is going to be. So in this case, A is going to correspond to the sodium phosphate. Next, B is going to correspond to 0.37, the potassium iodide. C is going to be glucose. And finally, D is going to correspond to sodium hydroxide. So the key is going to be D, A, B, and C.